In this highlight video, we're going to start learning how to name organic molecules. The process of naming is referred to as nomenclature. Okay, and there's really two different ways to name organic molecules. The first one is called common names. And common names are names that are given to molecules oftentimes even before the chemical structure was known. Sometimes the name comes from the name of the plant where the compound was discovered. Could be named after a person, things like that. So common names are kind of challenging because the only way you would know the common name is by memorizing it. We've seen a few common names already, like acetic acid or acetylene. And so we'll see some common names in this class, but what we're going to focus on is what we call systematic naming. All right, and systematic names use a system that's called the IUPAC system. The IUPAC stands for the International Union of Pure and Applied Chemistry. And these are the people that make up all the rules. Okay, so the advantage to using a systematic naming system is that we can deduce names by following some rules. We're going to start out by naming the alkanes, which are the simplest of organic molecules. Remember that alkanes are hydrocarbons that only have single bonds. So what we need to really do is learn the rules, and then we apply those rules to name molecules. As we go through this course and we learn new functional groups, each of those functional groups will have a few new rules that we'll keep building up so we can learn how to name more and more molecules. So in general, organic molecules have three parts. All right, the first part is called parent name, and this is based upon usually the biggest continuous unit in the molecule. Okay, so for alkanes, we're going to be naming the parent after the longest continuous chain. All right, and you should have already learned what these names are. These are the names for the straight chain alkanes, like methane and propane and butane and hexane and octane. So you should know those already. The next part is called the suffix. All right, so that's at the end, and that has to do with telling us what functional group is in the molecule. For alkanes, these names will be ended in ane. That's the suffix, and that tells us it's an alkane. The third part is the prefix, and this tells us the location and the number of the substituents that are attached to the parent chain. So the substituents are essentially different groups that are attached to the parent. Okay, and so far what we're going to be doing is you should know also what are called the alkyl groups. So this is going to be important. These are things that you should know. Okay, the first are the alkane names from 1 carbon up to 10 carbons. All right, so you need to know those. The second thing is that you need to know the names of the alkyl groups. Okay, and these are different carbon groups. To make an alkyl group, you take an alkane, like an ethane molecule, you take off one H so you can attach it to something else, and then it's called an ethyl group. All right, so make sure if you don't know those yet and you're watching this video, go back and look at that before you go on forward. Here's the big list of rules. All right, and we're going to see some examples of all of these, and so it'll make more sense as we go through. So let's look at the basic parts of this, though. The first step is going to be to find the longest chain of carbons. Okay, and we're going to use this as the parent name. We're going to name it just as a straight chain alkane. Okay, so if it has 6 carbons, is the longest chain we have in the molecule, we call it a hexane. If there's more than one chain of equal length that are present in the molecule, then we pick the one that has more substituents attached to it. All right, so after we've found the parent chain, we name the different groups, the substituents that are attached. Then we need to number the parent alkane. And this is going to depend on what types of substituents we have and where they're placed in the molecule. Okay? In general, we're going to number the parent to give the first substituent the lowest possible number. Okay, so we could number it from the left or we number it from the right, and we're going to choose the side which, when we count along the chain, it gives that group that's attached the lowest number. So these other ones are if we have some kind of tie. So if we have greater than 2 substituents where the same lowest number is obtained in counting from different directions, all right, then we're going to give the lowest number to the next substituent. So if we have 2 groups at 2 on each end, we have a methyl group at 2 and a methyl group at 2 from the other end, but we go another place and we have an ethyl at 3, but we don't have anything coming from the other direction, we'll count it to give the second substituent the lowest number. Then finally, if we have greater than or equal to 2 substituents where different substituents have the same position number counting from either end, then we're going to give priority to the substituent that is first in the alphabet. Okay, we're only going to use the last one if we can't solve the problem with the second one there. All right. We've essentially generated all the pieces we need for the name, and so now we're going to write out the name. We're going to alphabetically list all of the substituents in front of that parent name together with their associated place numbers. All right? Other things, if we have more than 2 of the same group, like 2 methyl groups, then we can say dimethyl. If we had 3 methyl groups, we could say trimethyl. So that tells us how many we have for each of those groups. We need to make sure that we have a place number for each of the substituents. When we alphabetize, we ignore any prefixes like di or tri or tetra or tert for tert-butyl or sec for sec-butyl. The only one that we do alphabetize is iso for like isopropyl or isobutyl. All right, seems kind of weird. Seems weird to me too, but of course I didn't make up the rules. So let's give it a try here. All right, so step number 1 is to find the longest parent chain. All right, the longest chain of carbons, which is going to be the parent. All right, so with this top one, we could just go straight away like this. We could also include down this way, or this way, as long as it's the long, each one of these have 5, so it doesn't matter which one we pick. Because this parent chain has 5 carbons in it, then the parent name is called pentane. All right, the second part was to name the substituents. So we have a methyl group here and another methyl right here. Okay, so we're going to list the methyl groups out in front of the name, but then Next thing we need to do is count the carbon, the parent. So if we count from left to right, we have 1, 2, 3, 4, 5. If we counted from right to left, we would have 1, 2, 3, 4, 5. And so in either of these, the first group is going to be at position 2, right? So this molecule is symmetrical, so it doesn't matter which of those ways we number it. It comes up with the same thing. So we have a methyl group at 2 and a methyl group at 4. So what we do is we say 2, 4, 2, 4 dimethyl pentane. Notice a couple of important things here is that between numbers, we use a comma. And between numbers and words, we use a hyphen. Okay? All right, so let's try another one. The next one down here has 5 carbons as well. So this is also a pentane. All right, which way are we going to number the chain in this case? All right, so in this case, because we have our methyl here and a methyl here, we're going to number it from right to left because that puts the first methyl group at position 2. If we numbered it from left to right, the first one would be at 3. Okay, so we have methyl groups at 2 and 3, so this is 2, 3 dimethyl pentane. Again, a comma between the 2 and 3, a hyphen between the 3 and dimethyl, and the last substituent runs directly into the parent name, all in one word. All right, one more. Okay, what's the longest chain? We can find the longest chain right here. That is 1, 2, 3, 4, 5, 6, 7. So what's 7? 7 is heptane. Okay, let's look at our substituents. Here's one, a 2-carbon substituent. This is ethyl. We got a 1 carbon here, was methyl like before. All right, and we have to number our chain. So we can number it from left to right. If we do that, we would number 1, 2, 3, 4, 5, 6, 7. That would put our methyl group at 3 and the ethyl at 5. The other way to number it is from right to left. 1, 2, 3, 4, 5, 6, 7. And so what we want to do here, we have essentially a tie. We're going to give priority to the substituent that comes first in the alphabet. So ethyl comes before methyl, so we are going to number this as we have in black. So we list the substituents in alphabetical order, and we give them those numbers. So we're going to have 3 ethyl, 5 methyl heptane. Let's do 2 more. All right, so what's the longest chain here? In fact, in this one we have 2 possible chains of the same length. All right, we have one that goes this way, Okay, we have 1, 2, 3, 4, 5, 6, 7. So this would be a heptane. Where else can we have a heptane? All right, the other way is to number it along this way. And this would also be a heptane. All right, so how do we break this one? All right, so the rule says, and this was up in rule number 1, is that if we have two possible parents, we choose the one that has more substituents attached. So the parent in blue has two substituents. It has this isopropyl and a methyl, but the parent in red has two methyl groups and an ethyl. Okay, so we are going to use the numbering that's in red. We're going to number it from left to right. 1, 2, 3, 4, 5, 6, 7. Because we have a tie, there's a methyl group coming in at the 2 position if we number it from right or left. So then we go to the next group, and so the next group is the ethyl group, and we give it its lowest possible number. Okay, so what do we have? We have 3 ethyl. We have 2 methyls, 2 6 dimethyl heptane. Okay, when we alphabetize, we ignore this in alphabetizing. Okay, so we're just looking at the methyl instead of the dimethyl. All right, one more. Okay, where's the longest chain here? All right, again, we have 2 possibilities. We have the chain that goes horizontal. Let's count those. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that has what? 1, 2, 3 substituents. Or we could count from up here at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. That also has 9. And how many substituents does that one have? It has the methyl, 1, 2, 3. That has 4 substituents. So we are going to we're going to follow this as our parent. All right, we have a methyl here. We have another methyl here. What's this one? That has 2 carbons. That's ethyl. And what about here? 3 carbons. That's propyl. All right, so we have 2 methyls. We have the ethyl. Let's number this. If we number it from the top, we have a methyl at position 2. If we numbered it from the right, we have an ethyl at position 3. So we number it from up there on top. 1 puts the first group at position 2. The lowest possible number for the first group. 6, 7, 8, 9. Okay, we're going to list our ethyl group first. 7 ethyl. All right, and then methyl. So we have 2, 5 dimethyl, 2, 5 dimethyl. And then we have the propyl is at 4. We have 4 propyl. No name. All right. So the trick to this is if you learn to follow the rules, how to break the ties, you can name almost any branched alkane. All right, so let's reverse this problem around, and instead of giving you a structure and have you writing the name, Here I'm giving you some names, and let's draw the structures. All right, so what do we do when we want, here's the first one, 2,4-dimethyl 5-propyl octane. Okay, so what we're going to do is we're going to look at the parent first, octane. So let's draw out an 8-carbon alkane. All right, so there's 8 carbons, and we'll just say we're numbering them from left to right. We have 2,4-dimethyl, so this is 1, so this is 2, there's a methyl there, 3, 4, 2,4-dimethyl, 5-propyl octane. All right, so there it is. Each one of these, what you should do is when we look back at it after you draw it, make sure that the name is actually correct. I will give you questions on the exam where I say, draw the structure and tell me if the name is correct. If it's not, give me the correct name. All right, so we would number it like this, right? That gives us the first group at 2. All right, so everything looks good. Okay, the next one is a heptane. So 7 is heptane 3,3-diethyl. So 1, 2, 3. Here's an ethyl, and here's another ethyl. So look, it looks like there's 3 ethyl groups all attached to the same carbon, but one of those ethyl groups is part of the parent. All right, this name is getting pretty long. The name is decane, so that's 10. 3, 4, 5, 6, 7, 8, 9, 10. Counting from the left, 6 isopropyl. 1, 2, 3, 4, 5, 6. Remember, isopropyl is a propyl group where it's attached to the center carbon. 2-methyl. 5, 1, 2, 3, 4, 5. Tert-butyl is a butyl group where we have all of them attached to a center carbon. So we have 3 methyl groups. Decane. All right, so is this name correct? Okay, the numbering looks right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Substituents are 2-methyl, 5 tert-butyl, 6 isopropyl. That all looks good. What about the name itself? Well, what about the alphabetizing? Okay, so remember, tert we shouldn't be including in the alphabetization. So this should be, the B should be used for alphabetization. And so, in fact, the tert-butyl should go all the way out in front. So it should be 5 tert-butyl, 6 isopropyl. Remember, the iso is included in alphabetization for some weird reason. 2-methyl decane. All right, so that one was in fact incorrect because of the alphabetization. All right, let's look at this last one. 3-ethyl 4-methyl pentane. Okay, there's our pentane, 3-ethyl, 4-methyl. Okay, how about, is that name all right? Well, not really. So in this case, this really should be numbered this direction, shouldn't it? All right, because that puts the first group at position 2. And so this really should be 3-ethyl, 2-methyl pentane. All right. So make sure to look in the book, work through more problems, get as much practice as you can at doing this kind of naming. It's really just a matter of following the rules.